Today we are going to review trig. I'm not going to do every example from this. I'll do at least one from each section, and then I'll give you time to work on the rest and be able to check your answers to make sure that you know how to do it for tomorrow's quiz. I'll go through at least one of each type with you and what we're going for there. So I'm going to go through number 3 from the first section with you here. So it says evaluate the 6 trigonometric functions of theta. So first thing we need to do is know what all 3 of the sides of the triangle are. So when we're missing one side of a triangle, we can use our Pythagorean theorem to find the third side. When you do the Pythagorean theorem, it is important that the hypotenuse is always the C value. So in this one, we're looking for the hypotenuse, but if we were doing this for number 2, 13 needs to be that hypotenuse, that C value. So make sure that your hypotenuse is always alone when you set it up. When we square this out, I get 121, which gives me 242. We want to simplify that square root. That's divisible by 121 times 2, because that's where it came from, which gives us then 11 square roots of 2. Now remember, for this quiz, you may use a calculator that only adds, subtracts, and multiplies and divides. But if it is a calculator with trig buttons on it, you may not use it for this quiz.
Since that's 11 square roots of 2, couldn't you just multiply 11 times square roots of 2 and leave that be the answer?
Yeah, that actually is a 45, 45, 90 triangle because the 2 sides are 11. So we know it's isosceles, and then we can follow that 45, 45, 90 pattern. And that would be a quicker way about this if you recognize that pattern there. The other 2 also are special triangles, not 30, 60, 90 or 45, 45, 90, but they're what we call Pythagorean triples, that they're quick to come up with a third side, 3, 4, 5, and 5, 12, 13. Like these are pretty special ones and easy to calculate without a calculator. If you know those patterns, you're going to see the same types of things on the quiz. So then to evaluate our 6 trig functions on this, we need sine, cosine, tangent, cosecant, secant, and cotangent. Sine is opposite of our hypotenuse, so then we need to know what the 3 sides of the triangle are according to the relationship with that angle. So 11 across would be the opposite, 11 next to it would be the adjacent, and the 11 square roots of 2 that we found would be our hypotenuse. So then opposite over hypotenuse for sine would be 11 over 11 root 2, which reduces to 1 over the square root of 2. You should reduce fractions when possible, but you don't need to fix the square root on the bottom. Cosine adjacent over hypotenuse turns out to be exactly the same thing. And tangent opposite over adjacent is 11 over 11 or just 1. The other 3, when we flip them over, square root of 2 over 1 will become just square root of 2. Secant, same thing. And cotangent, flip over a 1 over 1 is still a 1. Okay, so for these problems, a couple of things that you need to know. A squared plus b squared equals c squared, or special triangles. And SOHCAHTOA. Okay, so there are several things that for this quiz you're going to need to have memorized, and I would suggest as soon as the quiz is in your hand, you just write down everything, because then you'll have it to reference as you go through all the different types of problems. There are several things for this quiz that you'll need to have memorized, and those are the things that you'll need for this first group of problems. Questions on that type of problem? Okay, the next group says rewrite each angle in the other type of measurement. So if it's radians, turn it to degrees. If it's degrees, turn it to radians. What is our conversion between radians and degrees? 180 is equal to pi, so we're going to set it up as 180 over pi or pi over 180, depending on what we have. So again, I'm not going to do every problem here, but we'll look at like number 5. I always put it over 1 to make it into a fraction. And then I want to multiply it by 180 over pi or pi over 180. And I want to set it up so that what I'm given cancels, which means I want the 180 degrees on the bottom so the degrees cancel. Reduce our fractions. 30 goes into 180 6 times. That becomes a pi over 6. For number 6, since it has a pi on the bottom, I'm going to put on the top, I'm going to put the pi on the bottom so that those pi's will cancel. We always use 180 and pi. We set it up so that what we're given cancels. And to do this arithmetic, I would need to do 3 times 180 and then divide by 2. You can actually do your arithmetic in either order. You can do your multiplication first or your division first, whatever happens to be easier. I like dividing first because it makes things smaller. So 180 divided by 2 is 90, and then 3 times 90 is 270. Number 9 has degrees in it, so I'm going to put degrees on the bottom, which puts pi on the top. And then we want to reduce 14 and 180. Well, I can cancel out the 0, so dividing by 10, and then they both reduce by 2, so we have 7 pi over 9. So we're just going to do 180 and pi, set it up so that what you're given cancels. Questions on that type of problem? Okay, on the back, there are 2 types of questions, and these are trig of special angles. The first one's evaluate the trig function without a calculator. You're not going to have a calculator except for an arithmetic calculator if you want, but not a calculator that can do trig for you. So we're going to need to do some special drawing pictures for these ones. Every year I have quite a few students who ask me, what do these directions mean? Evaluate the function without a calculator. And all I can tell you is evaluate means figure it out. So that's really all it says is do the problem. You need to know how to perform the trig, and I'm not going to be able to walk you through that while you're actually taking it. So to evaluate a trig function without a calculator, our first step is draw the angle. So we'll go ahead and do number 11. So drawing out 270, begins at the 0 line. 270 is then our straight down angle. When our angle lands right on one of the axis lines, we want to look at that unit circle. This point on the unit circle is over 0, down 1. All of the points on the unit circle are alphabetically the cosine and then the sine. So this problem asks for the sine. So that means it wants to know what is the second part of that point, and it's -1. Skip down to 13. To evaluate 13, we need a graph in radians. To graph in radians, you cut each half of the circle into the number of pieces the denominator says. So we're going to cut each half of the circle into 4 pieces. Then the top tells you how many pieces to count out. So starting at the 0 line, go around 7 pieces. To make your triangle, always connect to the x-axis. How big is our reference angle? 45. 180 divided by 4 is 45. The sides of the 45, 45, 90 triangle are 1, 1, and square root of 2. negatives for horizontals on the left or verticals on the bottom. So the vertical one needs to be negative in this problem. Then we need SOHCAHTOA. So we look at that inside angle, the one that's labeled 45. Our reference angle is our angle we focus on. So SOHCAHTOA for sine is opposite, which would be the negative one, over the hypotenuse, which is the square root of 2. I'm not going to go all the way through number 14 with you, but on number 14, well, yeah, I will. On number 14, we want to go 0 degrees or radians, doesn't matter because they're both the same. So when we're on one of those axis lines, we want to look at our point on the unit circle, which is over 1, up 0 for this point, which is cosine comma sine. But we want tangent. What is tangent? Tangent is sine divided by cosine. So the sine is 0 and the cosine is 1. And 0 over 1 is 0. 1 over 0 is undefined. 0 on the bottom is a problem. 0 on the top is just 0. To add to our list of stuff that needs to be known for these, that unit circle, and when it lands on one of the axis lines, you need to know how to use your unit circle points. Cosine comma sine, tangent is sine over cosine, and being able to draw out those points. You need to know your 30, 60, 90, which is 1, 2, square root of 3. You need to know your 45, 45, 90, which is 1, 1, square root of 2. You need to know SOHCAHTOA again. So I only left one in this section for you to try, but it would probably be a good idea to try a few more. So how about cosine of 2 pi over 3 and tangent of 210. I'll give you a couple more that you can try out if you good ones to try. So the last type of problem looks a lot the same, except all the trig functions have that little -1 on them. That little -1 means inverse or backwards. So in the top group of problems, I gave you an angle, and our answer was some sort of a fraction. Okay? In the bottom group of problems, I give you the fraction, and your answer is the angle. The directions also hint to this, that our answer is an angle, because it says give the answer in both degrees and radians. So when the answers say both degrees and radians, those are types of angles, so that should clue you that your answer is supposed to be an angle. So we'll look at a few of these together. To do these, you're going to be using the same list of special stuff as the problems above. You need to know your unit circle, your 30, 60, 90, 45, 45, 90, and SOHCAHTOA. So first thing I do for number 15 is when it's not a fraction, I make it a fraction, and I think about SOHCAHTOA. So SOHCAHTOA for sine is opposite over hypotenuse. So I need a triangle that has a hypotenuse of 1. And I've got both the triangles drawn off to the side there. Neither one of them have a hypotenuse of 1. So that's not going to work. So if it doesn't work in a triangle, it must be in the circle. And in the circle, all the points are cosine comma sine, so I need the second part of the point to be a 1. The second part of the point is an up value, so I need a point that is up 1, which is on what angle line? The 90 line. to give our answer in degrees and radians, we want to think about how many times our angle goes into 180.
Half.
Goes in twice, so it's a half of 180 or pi over 2.
If you wrote 1/2 pi, would that be considered rounding?
Yeah, that's right. We just usually smush it together instead of saying 1/2 pi. It's kind of a laziness thing. For number 16, SOHCAHTOA for tangent is opposite over adjacent. So I'm looking for an angle that is opposite of a 1 and adjacent or next to a square root of 3. So what angle is opposite of a 1 and next to a square root of 3? 30, which is 180 divided by 6. And look at 19 here together as well. And 19, tangent of 1, I can make that 1 over 1. Opposite over adjacent for tangent. So I'm looking for an angle that is opposite of a 1 and next to a 1.
45.
Which are 45. And that goes into 180 4 times. And then I left a few more for you to practice there. So the rest of the class period to work on and practice the rest of these problems, and you can check your answers with the answer key up front.